You're going to see it for 3 seconds and then draw it on your own. On your marks, here it is. 1, 2, 3. You got 30 seconds to draw it, then we'll show it again. I'm going to show it to you again here in about 10 seconds. All right, here it is one more time. Ready? Going to show you for 3 seconds. Here it is. Da-da-da. 1, 2, 3. You got 1 minute to finish drawing it and write your equation. All right, here it is. Can somebody tell us what was your equation? Jonathan, what did you write for your equation?
6 times 6.
6 times 6. All right, so was this your group of sixes you saw right here? Is that where you saw your group of 6? Yes or no, Jonathan?
Yeah.
Okay, so let's count. 1, 2, 3, 4, 5, 6. 6 times 6? Are you still thinking it's 6 times 6? Ania, what is it?
6 times 7.
7. We got that 7th one over there, right?
How did you do that?
So 6 times 7. And what is 6 times 7? If you count
42.
all 42. Very good, right? Hopefully we're getting to the point where we're practicing these a little bit. We don't have to count every last little dot. But if we do, we do. All right. Here's your next one. You got another one. Are you ready? Clear your boards.
What is it?
I'm going to show you your next one in 30 seconds. So clear your boards. All right, ready? Here we go. 3 seconds starting now. 1, 2, 3. About 20 more seconds. We're going to uncover it again. All right, here it is again. Ready? I'm going to show you here in just a second. And 1, 2, 3. 30 seconds. Finish your drawing, write your equation.
Done.
All right, let's look at this one. Eric, can you share what did you write for your equation?
My equation. Okay. I think 4 times 9.
4 times 9 equals
36.
36. Let's double check. Let's circle our group of 4 to check. Let's count how many groups. 1, 2, 3, 4, 5, 6, 7,
No.
8. Do we want to make a change?
I mean, yeah, I did. I was wrong.
Okay,
So
so
4 times
4 times 8 equals
32.
32. Do we agree? Guadalupe, do you agree with him? 4 times 8 equals 32 is our equation for that drawing? Yes? Cool. All right. Moving on. Go ahead and clear your whiteboards. Today, we're going to go through and we're going to look at using strategies to break numbers apart and solve larger multiplication problems. We're going to just do a little bit of strategy review and then take a quick quiz, all right? That being said, we're going to start with yesterday. We had these problems, right? 15 times 8 equals 120 and 30 times 4 equals 120, all right? So what do we notice is the same? We did these problems with Mrs. Santos's apples. What do we notice is the same in these two equations? What is the same? Mary Lay, what's the same in those two equations?
The product.
The product. And you know what, Mary Lay? Pat on the back to you because you didn't just say the answer. You didn't just say 120. You used that math language and you said the product. The product is the same, right? Both of those are 120. Is there anything special we know about the factors? What do we notice about those factors? Ania.
If we double 15, it'll equal 30.
So if we double 15, it equals 30. So yeah, that 15 times 2 is 30. That's doubled. Very good. What about the other factors? 8 and 4. What do we notice about those? Oscar, what do you notice about those factors 8 and 4? With doubles and halves. Which number there is half of 8? Anybody want to help him out? You can unmute yourself and help him out. Which number is half of 8?
4.
4, right? So this is going into that thing we talked about yesterday, where if you double one factor and you have another factor, your product stays the same. And I'm going to show you what that looks like visually here. So imagine this array is our array for 15 times 8, right? Right here. And we cut that 8 in half right down the middle to make it 4 and 4. And we put those two halves. We put one right here and we put one half right here on top of each other. Now, because we had 15 here before, right? This 15 was this length was 15. Well, now we have two of those. So we have 15 here and we have 15 down here. So we doubled our 15 to 30 and we cut our 8 in half to 4, but we stacked them on top of each other. Are those the exact same amount? Did we change the amount we had right there? No, I see Eric shaking his head. No, we didn't change the amount. We just changed the way that it's arranged. So anytime, we got to remember that rule. Anytime we double one factor and we have the other factor, what happens to our product? Anytime we double one and we have the other one, what happens to our product? Let's go back to this slide. We doubled one factor, right? We doubled our 15 to 30, and we have our 8 to 4. What happened to our product? Jonathan, what happened to our product?
It stays the same.
It's equal. It stays the same. This is a motion for equal, right? It stays the same. They're equal.
Yep. Thank you. So anytime you double one factor and have the other one, it stays the same. Anytime you double one, what happens to the product? If all we do is double one, what happens to the product? Ania, if we double one factor, what happens to the product?
If we double one factor, we double the product.
Very good. If we double one factor, we double the product. Everybody say that. If you double one factor, you double the product.
If we double one
If you
factor,
double
we
the you double one factor.
Double the product. Thank you. Eric, what happens if we have one factor?
We double it?
Nope. So let's say, hang on, I'm going to write over to the side. So let's say we had 4 times 4 equals 16. What happens if we have one of those and make it 4 times 2 equals 8? When we have one factor, what happens to our product?
We cut it in half.
You cut it in half. Yep. So when you cut one factor in half, you cut one product in half. Moving along, I want to talk about some of the strategies you guys have used for larger multiplication problems. So we're going to look at 2 examples, 14 times 6 and 35 times 3. Okay. And I want you to take 5 minutes right now. All right. And on your whiteboard, I want you to solve 14 times 6 and I want you to solve 35 times 3. Okay. I'm going to give you 5 minutes to solve those. Then we're going to come back and we're going to share our strategies before we go off to take the quiz. All right. So 5 minutes, solve 14 times 6 and solve 35 times 3. Go. You got 5 minutes. Setting a timer on my phone.
Mr. Hoffman, are you making the groups quicker today?
We weren't planning on it.
Well, just because you said you're going to send them off.
Well, I mean, we're going to let them start working on the quiz. We'll probably take the
Okay.
quiz in groups. Most of the kids in this group have the read aloud accommodation.
Okay.
So we'll probably just do it in groups, put them in breakout rooms or something. I'm noticing Eric using some strategies to solve the problems. Nice job. I'm noticing Ania and Guadalupe and Jonathan using their whiteboards to solve the problems. Nice job, guys. You guys have 2 minutes. 2 minutes left.
I did one answer.
One more minute. About 30 more seconds, guys. I'm going to come back and talk about these two problems. And it's okay if you didn't get all the way through both. We'll talk about strategies for both. All right, everybody, let's come back together and look at the first problem, 14 times 6. Is there anyone who would like to share with us your strategy and what you did to solve 14 times 6? Jonathan, I see your hand. Go ahead, unmute yourself and talk us through what you did to solve the problem.
So I drew 6 circles.
All right, hang on a second. We got my pen's going here. All right, 6 circles. Okay.
And I counted by 4, and I put number 14 in all of them.
All right. Okay.
And then I counted by 14s and put the number on top of them.
Okay, so talk us through 14.
28, 42, 56, 70, 84.
84. All right. Just by a show of hands, give me a thumbs up if you also got 84 for that problem. Guadalupe says thumbs up 84. Anybody else get 84? Oscar? Eric? Ania, I don't know if something's going on with your camera, girl. All right. Just so I want to be a little clear here. Another great way to do that, if you're just going to count by the number rather than drawing 14 in every circle. Do you guys remember when we did multiple towers? So you could make a multiple tower and count by the number and say 14. 14, 28, 42, 56, 70, and then 84. So you could do a multiple tower, right? Another thing you could do, did anybody break apart the 14 into friendly numbers? Anybody break apart the 14 into friendly numbers? Okay, I'm going to review that strategy then. Looks like some of us use repeated addition, which is an okay strategy too. Let's look at if I drew this as an array, right? And I had 14 and I had 6. What's a friendly number I could get out of that 14? A really friendly number. Mrs. Fleischer says it's the most friendly number. Guadalupe. 10, right? So I could split my array into 10 and what? If I split 1, 10, what goes down at the bottom is the smaller part. 14 is 10 and what? Guadalupe, keep going. 10 and what?
4.
4, right? 10 and 4. So since my number 6 didn't change, I'm now going to multiply those both by my 6, right? So I'm going to say 10 times 6 equals what? Anybody can unmute and tell me.
60.
60, very good. And I'm going to say 4 times 6 equals, anybody can unmute and tell me. Eric, what's 4 times 6? I know you know that fact.
I think it's 24.
Yep, 24. And then what am I going to do with those two answers? Mary Lay, what am I going to do with those two products to find my whole answer? I'm going to add them. So I'm going to do 60 plus 24. And just like Jonathan got, I'm going to get 84 for my answer. All right. Let's go over to 35 times 3. Can anybody share with us what you did to solve 35 times 3? Besides Jonathan, because he shared his strategy in the first one. Ania, go for it. What did you do to solve 35 times 3?
I did 35 3 times,
So you mean you added them like this?
Yes.
Okay.
And I had to regroup, so I counted by fives, 5, 10, 15, and I got 15. So I put the 5 down like at the bottom, and then I put the 1 up in the yeah, right there.
You put the 1,
then-
the 10. You put the 10 in the tens place.
Yes, and then I knew that 3 plus 3 was 6, so 3 plus 1 would equal 4. So I added those together, and I got 10. So my answer was 105.
105. Okay. Anybody else? Got thumbs up if you got 105 for 35 times 3. Good job. Good job. Again,
Eric, what did you get? You gave a thumbs down.
It's because I didn't get a chance to do 35 times 3. That's why I did this.
okay. You didn't finish. That's okay. Okay. Let's go through again. I want to split this into friendly numbers. And here's the deal, y'all. We've spent this week talking about multiplying multiples of 10. So I want you to watch this. If we split this 35 into 30 plus what? 30 plus what? What number is going to go over there, Oscar? 35 would be 30 and what number? Oscar? 35 would be 30 and what? You're muted, dude. Oscar. 30 and what?
Um,
35 would be 30 plus how many ones?
30.
Not 30 ones. We have 30 and how many more? Somebody help them out. Unmute and tell me.
5.
5. Very good. Thank you, Mary Lay. 30 plus 5. Mary Lay and Guadalupe. I think you both unmuted and said it. So we have 35. So then we have practiced these big multiples. So now we're going to take 30 times 3 and we're going to take 5 times 3. So let's do 30 times 3. What math fact do we know that we can use to help us solve 30 times 3? What times what? If we change that 30 into ones. Ania, what math fact could we use to help us solve 30 times 3? If we ignore this 0 and pretend it's not here.
Uh, 3 and 3.
3 times 3. Yep. 3 times 3 is what, everybody? Anybody can tell me.
9.
9. Now, because it's actually 30, that means that 9 goes in the tens place, and we have to put what in the ones place? What goes behind that 9? Anybody?
12.
3.
No, 0. Right? Because we're really doing 3 tens. So 3 times 3 is 9, but it's 30 times 3, so it's 90. And then what we have left is 5 times 3, and that equals 15. Then we add them both together, and we get 105. Same answer, just a different way to solve it, okay? So when you go to do the quiz today, all right, we're going to break you up in groups here in a second and send you to breakout rooms or keep you in the main room. And we're going to work on that quiz. We have about 20 minutes to do it, okay? And then if you haven't finished, what we're going to do is when we send you out to work on your own, we're going to have you finish the quiz first, okay? So I'm going to stop. I want everybody to go ahead and get on Canvas. You're going to go to Wednesday, and you're going to go to Math. Wednesday, Math, and then Quiz 2. So you should open up your multiplication quiz. Starts with this, okay? Multiplication quiz looks like this.
Okay, we're gonna do it.
Okay. So then I'm going to send a few of you to breakout rooms. All right. I'm going to send a few of you to breakout rooms, one group with Mrs. Fleischer, one group with Miss Weibel, and we're going to work with you for 20 minutes in those breakout rooms before we send you out to the waiting room. Okay.